who will be speaking about the quality aspect of the transformers. We have Sri Amandeep Singh, TGM from Power Grid Corporation again, who this idea was first discussed with Sri Amandeep Singh, and who was very, very supportive all the time and has been guiding how this seminar and how can we really achieve our objective in this field. So thank you very much, Sri Amandeep Singh ji, for your all the efforts and initiatives in this. And we have Sri Richik Das, the Chief Manager from Power Grid. They all will be focusing on each specific topic. I would like to speak about them a bit more when that time comes. Now, welcome, sir. I can see Dr. Jagat Reddy also, Director Transmission from Telangana, Hyderabad, he has joined. And Dr. Jagat Reddy has written a wonderful book also of almost 1200 pages on transmission and transformers, which soon I think would be available on Amazon also. The digitized copy will also come on Amazon. So first of all, I invite Dr. Jagat Reddy to please speak on his experience in this field, in the field of transformers. So Dr. Jagat Reddy, Director Transmission from Telangana Transco, Hyderabad.
Mr. Sanjay, can I give a presentation or I have to just talk about it?
That will be great, sir. Whatever you have, sir, 15 to 20 minutes at the first stance. Every speaker is given around 15 to 20 minutes. So I request to please keep the talks confined up to 15 to 20 minutes. After that, we have half an hour of interaction with the interested people, with the manufacturers and other people. So it is up to you to decide. Yes, sir.
Yeah, I have a presentation just to present. First of all, I can start with that. Otherwise, it's difficult for me to talk up there. So my presentation is ready. Can you give me a chance to give the presentation?
Yes, sir. You can share the screen. You have the screen sharing rights. You can share that. We are ready.
Sir, excuse me, sir. It is showing host to disable the participant screen sharing, sir. That pop-up is
I think you have disabled us to share the screen. Hello,
He is doing it, sir. He is doing it in a minute. That organizer is doing it. In the meantime, sir, they are doing. You can show that book. You can share something about that book, which is widely getting talked about everywhere.
I'll do that. English version level.
Yeah.
So first of all, Mr. Sanjay, I think with his love, he is calling me as doctorate. I am not doctorate. I am pursuing my doctorate. I have written the examination. I am yet to submit my thesis. I don't call myself as a doctorate. Please let it be very clear. And of course, the thing is during the COVID period, our training center was idle. Our training center was idle, and before that, some accidents and equipment failures were happening in our substations, and those things. At that point of time, we thought of giving training to all of our people, in the process, one of our generating station has at Kottagudam has stopped. Has been stopped, and 200 people were idle in the generating station. Our board was thinking of where to accommodate these people, Just a minute, sir. Done. బిజీగా ఉన్నాను, కొద్ది సెమినార్ అవుతుంది, 1 hour తర్వాత. We thought of, I said there was a ban in recruiting the people for the new substations, and we were deputing the people from other substations to manage the newly constructed substations. So then I requested my chairman, sir, give me those 200 people to our Transco, from Genco to Transco, and I will accommodate them in our substations. Then he said, how do you accommodate? They have all working, they are all working in the generating stations. How do you teach them? How do you inform them? How do you educate them to work in the generating, means our EST substations? Then I said that I will give the training to all those people. And he has readily agreed, and to depute the people, 200 people, to generating station, to transmission substations. Then immediately I have contacted my training center, and we have prepared a schedule for giving the 14-day schedule for giving the training to those people. And those people have been trained by almost all departmental experts, departmental engineers only. And of course, we have given the training, means in the training program, we have taken the services of fire department and medical department, and these first aid services department, yoga, everything has been included in the training. And 200 people were given virtual training from our training center for the people who are at all the substations. We did not call them here. Virtual training has been given. It was a COVID period. Virtual training has been given. See, after deputing the people from Genco to Transco, they were trained, and we have placed them in different substations. There was an accident in Srisailam Power Substation at the same time in 2019 August, and some people who have been trained came there to the accident site, and there was a condolence meeting. There the people have given our training feedback, that saying that excellent training has been given in TS Transco for the Genco people, and the feedback was very, very nice, very nice. Then I thought of giving the training to all the Transco workmen, means diploma engineers and ITI people and basic level assistant engineers also. Around 3,000 people were there. We have prepared the training program for all these people, 9 days virtual training program with 99% attendance, with 99. So selecting about 64 substations, 10 people at each place. Half-day training, half-day practical training, half-day theoretical and half-day practical. In the process of this training, I have taken the classes of all these batches. 7 batches, 500 people in each batch we have conducted training. And during the training program, some questions has been raised and people have answered. See, people raise the questions, they will take the answers, but very soon they forget about it, and again they try to contact them. I thought that it is better to keep it in the writing form. It is in the form of in writing about all these questions and other things. Entire training program lectures has been rerun by our training centers, and all the questions has been taken. About 3,500 questions has been placed by the people before the faculty, and faculty has given the answers. Many of them repeated questions also, of course, because the training was conducted in 6 batches. So we thought that after this training program, when we were doing it, we give the answers to each question placed, and it has to be placed in all the substations available. It must be available for all the people all the time. So then we have compiled the questions. All the questions has been compiled, and the answers has been prepared by the respective resource persons, and a committee, because we wanted to publish it in the form of a book. A committee of 18 people has been appointed for vetting each question. The shortlisted questions were 1,400 numbers, and 18-member committee sat for about 28 days, 12 hours a day, and for getting the common reply for each question from 18 experts. So that has been printed in the form of a book. That has printed in the form of a book. Of course, I am showing it. It is translated into Telugu language also, which is the language of Telangana state. It is in English and Telugu as well as. This contains 1,400 questions and answers. Each whatever equipment, all the equipment that has been utilized in the substations and the lines maintenance has been included in the question. If it is a line diagram, if you take a line diagram, single line diagram, first equipment that comes in the substation, that comes in the network is our lightning arrestor, and this is about the lightning arrestor. This is about the what is lightning arrestor, what type of lightning arresters are there in the system, and the purpose of what is the purpose of the lightning arrestor in a substation, and what are the frequent problems that come in our day-to-day functioning, has been answered by the people, 18 expert committee members. And similarly, every equipment that is there in our transmission system has been described. First of all, what types of circuit breakers are there, what types of CTs are there, all has been discussed in the book, and what are the frequent problems that are arising out of this equipment from the substation, within the substation, has been answered. And it is in publishing, only limited copies has been published for release of the book, and we are publishing in a big way. And to keep all these books, means Telugu and English books, in our all substations, so that it will be available to all the people working in the substations. And I just want somebody, you can raise any questions about this book, and we want to share this book on cost basis for all the people. If anyone interested in this, I think because the knowledge has to be shared to the people, information has to be shared to the people. That is the idea of our chairman and managing director, Mr. Prabhakar Rao. And only with his support we could do this. All this has been done with his permission at every stage to conduct the training to 3,000 people in 7 batches. And training has been given to central breakdown station working people. Training has been given to the substation operators, system operators, and the maintenance engineers. To everybody, it is only to save the equipment for maloperations, save the people from accidents, This is the English version of the book. It is around 1,200 pages and 1,400 questions and all details about the transmission network, transmission systems that are there in the system has been given itself. And anything about the book, if somebody wants, you can ask for me, you can put your questions. I'm ready to answer it. So otherwise, I'll just go ahead with my presentation to the people.
Yeah, please, sir, go ahead with the presentation. Question answer we will take later on.
Yeah. You can see the contracted capacity. I just want to brief about our transmission, Telangana Transmission Corporation. Just 2-3 slides, and directly I'll go to the transformers. And we have a generation capacity of 18,000 megawatts. It was 7,700 within 8 years. That has been more than double. Solar capacity also, peak demand also. From it was 5,600 megawatts to 15,497 megawatts within a span of 8 years. Consumption also 128 million units to 297 million units per day. the peak demand that has been achieved. And the substations also, there were at the time of formation 2014, it was 6 numbers of 400 kV substations. So now it is 19 numbers and 220 kV substations from 51 numbers to 100 and 130 kV substations from 176 to 276. Total EHT substations 33 to 376. 376 and transmission network length has been increased by 11,500 circuit kilometers. Particularly, the increase is in the 400 kV network. Only 1,600 circuit kilometers line was there as on the date of state formation. And now it is 6,500 kilometers, almost 5,000 circuit kilometers of 400 kV network has been added. And the transformation capacity including lift irrigation substations, it is 39,313. When the state has formed, it was 14,973 MVA. Now it is 39,313. Out of this, at 132 by 33 kV level, it is 27,000 MVA. And the demand means per capita consumption of the state is, it was 1,200 units. Now it is 2,071 units in the state. I think one of the biggest power consumption state. We have a network of 400 kV network ring around Hyderabad, and about 80 to 100 kilometers away, another 400 kV ring, and about 200 kilometers away, one more 400 kV ring. All these lines are connected to the generating stations, substations, lift irrigation substations, interstate connectivity, network connectivity is also. The next one is means it's setting around Hyderabad, 220 kV ring and then 400 kV ring around Hyderabad. I'll just skip some of the slides also. The state demand, district-wise state demand has been increased. Almost every district has one except Hyderabad. All the districts, the power demand increase is more than 100%. It is 149 and 162% in one of the districts in our state. Our system losses has been reduced from 4.3% to 2.52%. For a period of 8 years, the system losses has come down, and transmission availability of the state is around 99.98%. The transformers, number of transformers in our system is at 400 by 220 kV level is 56 numbers, 400 by 13.8, this is lift irrigation substations, 7 numbers, and 400 by 11 kV is 2,890 MVA, 33 numbers, 220 by 132 kV. We have 176 transformers, 33 by 132. One step of transformer is there, one at NTPC solar generating station, and 220 by 33 kV system also. We are now going very recently. We are wherever the 220 kV line is available, we are tapping that line and directly going for 33 kV, 220 by 33 kV. And 220 by 11 kV is again, this is a lift irrigation substations. 220 by 6.60. This is water grid substations, means Metro Water Works. For Hyderabad Metro Water Works, we are getting the water from Godavari to Hyderabad and Nagarjuna Sagar to Hyderabad for drinking water purpose. And 132 by 33 kV level for giving the power to the distribution companies. It is 610 numbers of power transformers. All these are 31.5 MVA, 50 MVA, 80 MVA. We are phasing out the 31.5 and as well as 10 bar 16 MA. We have some 10 bar 16 MA transformers also, old transformers. We are phasing it out and we are not buying any new 31.5 or 10 bar 16 MA transformers at 1.2 by 33 kV level. We are going for procurement of only 50 MA and 80 MA transformers at 132 by 33 kV level also. At 220 by 132 kV level also, we are phasing out we are not going for procurement of 100 MA transformers. We are going for procurement of only 160 MA transformer. In future, we'll go for 200 MA transformers also. 220 by 132 kV, 200 MA, or even we may go for, we have not done so far, we may go for 250 MA at 220 by 132 kV level also. And this 132 by 33, 11 kV also, it is lift irrigation substations. These are all lift irrigation substations. And the failed with these are all the failed PTRs. In 2014-15, we have two power transformers have failed. And 15-16, 6 numbers, 16-17. The total population of the transformers also are given. It is 561 transformers as on 2014-15. And out of that, 2 numbers have failed. The percentage failure rate is 0.35. And 15-16, it is 638 transformers. And the failure of 6 transformers have failed. And percentage, it is shown everywhere. The failure rates means the transformers failed are given, and the maximum percentage is 1.14 in 17-18. And next is 2022, 23, 21, 22. It is 11 numbers have failed. And these are all the details of the transformers failed. So many of the transformers which have failed, is the guarantee period 1 to 5 years. The OEMs. Guarantee period, failed in guarantee period, given guarantee period. See, these are all the transformers failed beyond warranty period. Details of the transformers which have been. And we have discussed with the manufacturers, and all these transformers, around 30-35 transformers, has been repaired by the manufacturers. Next slide. Wherever beyond guarantee period, whenever a transformer fails beyond the guarantee period, we are not directly sending it to the repairer. If it is beyond current, we are opening the transformers at the site itself, and about 35 last 8 years, we have repaired these transformers at the field itself. Mostly when the transformer is failed, it is the failure means the minimum means or whatever it may be, very minimum things that has been repaired at field. Around 35 transformers has been repaired at field level. We are opening the transformer in the substation itself, and looking at the faults and repairing it, and putting the transformer back into the service. Right. We have we have some issues with the transformers also. Some of them which have been procured have failed within 5 years. A sizable number of transformers have failed, and when they are opened, the process of manufacturing has to be taken into account. This type of when the transformer is opened at the field, these are all the issues that has been found in the transformers. all these transformers, this transformer is opened at our field. There is a thermal fault in the transformer. There was a thermal fault in the transformer. We have opened it and so we got it corrected and put the transformer into service. It is the clear manufacturing defect. Means in the process defect. See, I know that the company doesn't want to do this, but these transformers are assembled by the people. There must be a perfect supervision while manufacturing the transformers. I'll show you the little difficult, some of photographs which we have observed. Here I am not naming the manufacturers. I am not naming the manufacturers. The deficiencies observed. I'll just hand it to my colleague who is in charge of the transformers.
Sir, I have a request to make. Sorry to interrupt. We in 2 to 3 minutes, if possible, try to wind up. We will come back to you again because the other speakers are also waiting. But so far, I find that the transformer failing is one of the biggest challenges that Telangana transmission has faced. So my sincere request is if your colleague could wind up in next 3-4 minutes, then we move to Mr. Gunjan Agarwal from PGCIL, who also have the same topic as the quality issues, which almost matches to your concern. So, sir.
Okay, then I will skip it. See, when the transformers which have failed within 5 years, when it is opened, mostly it is the process of manufacturing that has been taken by the people, workmen in the manufacturing process. Have made the transformer fail. And of course, we have experience within 5 years, from 5 years to 10 years, all these details we have got. And as Mr. Sanjay said, I will finish it here and we will discuss it. We have some points that has been observed in the quality check, means stage inspection check also, stage inspection, different photographs we have got. In the process of, means before, just you see the clearance. So where is the clearance for this new transformer? Okay.
Thank you very much, sir. Very
Okay,
enlightening. Your book, and especially the time that COVID time you utilize excellently for training your team. And training is something which is very, very essential. We all need trainings at different parts of time. So with this, sir, I move to Sri Gunjan Agarwal, General Manager, Power Grid, and who also has the similar topic, almost same, the quality issues, which Dr. Sri Jagannath Reddy sir was trying to cover. So I invite Sri Gunjan Agarwal, General Manager, Power Grid, basically focusing on the issues relating to the quality of the transformers and how can we improve it. What are those small things that need to be taken into account? Sir.
Thank you, Sanjay ji. Good morning to everyone. I'm Gunjan Agarwal, right now working as General Manager in Power Grid Regional Headquarters, Lucknow. Before that, before coming to this place, I have worked in Corporate Engineering Department and Corporate Asset Management Department also in the past. And before that, I have worked in substation also. So, major challenge for today is the quality aspect of the transformers, because no utility wants that their transformer should fail, and no customer also want that the transformer should fail. Even manufacturers also don't want that the transformer should fail. So as far as Power Grid is concerned, sir, we have a large base of transformer, reactor and transmission assets. As on date, we have more than 2,70,000 crores of our assets, and maintaining that asset with availability of more than 99.84%, is a huge challenging task, especially we are one of the largest utility transmission utility in the world. So our asset base includes mainly 765 kV network, which is the largest network in the world. We have large number of transformers, HVAC, HVDC, STATCOM, and other applications also. So we are maintaining that asset with quite efficiently, and failure rate is very less compared to international failure rate. Still, there are some failures and quality aspects that we control at the manufacturing works and at site also during commissioning and during O&M. So when we see that just as CEA has already finalized one technical specification, we PowerGrid contributed a lot in many chapters, including design aspects, O&M, how to do that O&M, and now that specification is freeze, and there are some clauses, many clauses for manufacturers also. So how to select the manufacturers, what should be their quality plan. So all these things are there, and all utilities have to insist and follow those specifications so that failure rate should be minimized. And these issues should be taken up with the manufacturers. So basically my talk will be covering three aspects. One is the new emerging challenges, then the existing facility challenges, what are the facilities and what challenges we are facing, and next is the field quality. So how the quality at the field is being maintained and what are the issues. So if we see about the new emerging challenges as per CA specification, we have to go for the short circuit test of the transformers. And this is one of the tests which is very useful. We have seen in our network after short circuit testing and using that design, a lot of failures in our system of transformers have been arrested. By short circuit testing, we ensure that the design is foolproof, and especially during the secondary side faults and in the underlying system faults, the transformer should not fail. So major aspects, what utility have to see and what manufacturers have to see in this regard is that whatever design the manufacturer is offering, that design review is being carried out by the utilities, and that design should be verified at manufacturing works. After short circuit testing, proper checks are there. So utility should involve in those tests, and after passing that short circuit test, that design should be followed by all utilities, because there is no need to carry out short circuit test by every utility if the design is same. So the beauty of the CA document is that they have already finalized the ratings of the transformers which utilities should use. So certain specifications and certain ratings are finalized. So utilities try to follow those ratings only and should not insist any new type of rating. So that will give a big boost to manufacturers also, because then they have to follow certain designs only. No frequent design reviews will be there, and that design will be proven design. Nowadays, we know that there is a use of ester oil. If we see across the globe, we are going for low carbon footprints. This is one of the major criteria. When we see ourselves globally, so globally, including our investors also, they insist that whether your utility is having low carbon footprints or not. So we are doing some projects with ester oil, 400 kV rating transformer reactors, and we are also now going for 132 kV rating also. Other utilities in India also following this ester oil. So at factory, if we see, it is a big challenge for the manufacturers and the utilities regarding the manufacturing quality plan for this ester oil. So there should be a clear criteria that there should be a separate system for the dealing with the ester oil, how they are used in transformers. That system, including the filter machines, including the hoses, everything that should not mix with the other type of mineral oil. So this should be a challenge for all manufacturers. Next is the design optimization. If we see, as I have already told, that design should be minimized and it should be optimized. So because nowadays cost is one of the important factor for all the utilities. So every day some design changes are going on, some new material is coming, some new designs are coming. Manufacturers tries to optimize their design. However, there should be a proper criteria for that. Proper design review should be there, and any new design, if they are suggesting, then it should be properly tested with short circuit test, with other type test, and then only it should be followed largely in the grid. So every utility and manufacturers, they should have proper design team, proper design tools at their factory, and every utility should have design engineers, and they should check the design the manufacturers are offering. They should have the capability that they should check the design what manufacturers are offering. Then best practices for manufacturing is also one of the criteria, because large number of manufacturers are there in India, and we largely now depend on Make in India. This is a very good thing that we have very good transformer manufacturers in our country, but more number of new transformer manufacturers are also coming. We are also welcoming them that they should come, so that there should be a proper competition. But the manufacturing practices, what they are adopting, it should be a world-class facility. Otherwise, they will have bad name, and utilities will have to suffer with that design. Even across the globe also, we see if the design is not proper, then it gives a bad name to our country also, not only to that manufacturer. Then development of indigenous new sub-vendors. So this already we have seen that whenever a new vendor is coming, we should standardize their manufacturing quality plan. It should be compared with the existing best class manufacturers. So these are the new emerging challenges for all manufacturers and utilities. Others are also there, but I have covered some aspects. Then if we see the existing facilities challenges we are facing, one is the working environment. So as Power Grid is ensuring that there should be a proper working environment for at the factory, proper dust level should be there, windings should be manufactured in air conditioned environment, and moisture should not ingress in the transformer during the manufacturing. So, and general cleanliness of the plant is also very important. Dust level we are monitoring. We have certain criteria. What should be the dust level? And I think manufacturers will also appreciate that Power Grid, by doing such stringent measures, they have developed many manufacturers, their manufacturing processes, their plants, their tools. So now they know that what should be done as per requirement of Power Grid, and which should be matching with the global requirement also. So this is a very important aspect regarding workmanship. Workmanship is one of the issue. Like if we see very skilled, unskilled manpower is there at the factory. So that manpower, whether they are able to, they are having that certified manpower, certified binders, various quality checks are there or not. Their quality person is a key person. He should go at various checks. He should have every manufacturing, after every manufacturing, every step, there should be a quality check at the factory. So if it will be there, then the quality of the product will definitely better. Another major aspect is the material. So whatever material they are using. So now, because we know that whenever some small transformer, some utilities, small utilities are there, or distribution transformers, so quality of material is one of the major issue. So there should be a proper system or checks for the material at factory. And utility and manufacturers also to ensure that this transformer should work for the desired life. Otherwise, they will also have to suffer a lot. Every time they have to take back the transformer at their works for repair, or they have to send their representative to site to meet any defect or any failures. So utility and manufacturers both suffer if the material is not proper. They should have proper established processes, well-defined processes, standard operating procedures. If we see about the handling of oil is one of the major issue at manufacturing works. So whether that oil they are using, because generally manufacturers use old oil at their factory and they repeatedly use that oil for testing of the transformers, and new oil is directly supplied to site. So whether the old oil is good or not, their quality is being checked or not, their resistivity, IFT, 10 delta, all these things are good. Filter machine should be good, clean, hoses should be clean. If it is ensured, then lot of problems in the transformers will not be there. Then the equipment at factory, there are the major challenges is the breakdown of their testing kits. So testing instruments, healthiness of the testing instruments, their calibration, the maloperation, maintenance of these test kits is very important, because most of the manufacturers, the testing kits are very costly at the factory. So if their testing instruments are not good, then the supply will be delayed and the testing will also be suffered. So proper calibration should be there. If we are measuring the losses of the transformers, then it is also one of the important criteria, because losses we define the losses in the specification, and if those losses are not met or sacrificed, then it is directly dependent to the cost of the transformer. So utility should be aware about this, and manufacturer should adopt good practices that they follow the defined losses. Another important criteria, after we move from factory to site, the transformers are transported to site. So field quality plan is there. So transformer, they should check manufacturer that the plinth is good. There should not be any undulation in the plinth, because it will lead to vibrations. So civil work is very important. Power Grid has standardized their foundation design. So now we are having interchangeability. So that aspect we have covered, but all utilities should see if they follow the same design, same specification as per CA, then their transformers will also be interchangeable with other utilities. So in case of any failure, they can request other utilities to immediately transfer or shift the transformer. So water logging, if storage is also very important criteria, like water logging is there or not. We have seen that many accessories, pipes, etc. get rusted at site because their storage is not proper. The bushing, if we are using polymer housing bushing, then their sheds get damaged, moisture get ingressed in the transformer bushings. So all these aspects are very important, storage aspects. Then after receipt of transformer or reactor at site, then checking the condition is also an important criteria. So everything is healthy, no damage is there, dry air is proper, their pressure is proper, dew point is good, everything. Impact recorder also, we are specifying impact recorder for power transformers, all transformers. So impact recorder readings, if there is any violation, then that we will take care with the manufacturer, that if there is certain jerk in the transformer, then additional checks are there at site. And if something found damaged, then we send the unit back to the factory also. So these issues we face at site. Then handling, how they are handling at site, like during erection, the bushings are being handled, other accessories are being handled. So handling is also a major aspect. And field quality plan. There should be proper field quality plan of all utilities. There should be proper pre-commissioning checks. If you see the CEA document, all pre-commissioning checks are mentioned there. So utility should follow, and manufacturer should also follow all those checks. We have seen that because of poor filter machine at site, the oil quality gets deteriorated, new oil quality gets deteriorated, and then we face lot of time to recover that oil. So these aspects should be there. Otherwise, manufacturer also suffer and utilities also suffer. Our commissioning time gets extended. Then after that, we do the testing of the equipment and interpretation of the testing. There should be proper testing instruments, quality testing instrument. They should give accurate results. And then interpretation of that test results is also a very important aspect. We have seen that lot of times major problems, if you see at site, we face that core insulation is not good, bushing 10 delta is bad, winding 10 delta is bad. So if we follow all these things from manufacturing factory to site, then and properly commission the equipment, then it will work for its desired life. So this is what I want to say regarding quality aspects. There are many more aspects, but other speakers also have to speak. And if there is any query, then I'm here. Thank you, sir.
Thank you very much, Kunjan sir. You have covered very vital points, and I'm sure there are more than 90 manufacturers, transformer manufacturers. My team has told me who have joined this, and even people from the places as far as UAE, Dubai, and even one person from US, they are listening to your advices and talks. And I'm sure they will make a wonderful impact on the minds of these people. With this, sir, I come now. Jagat Reddy sir, Kunjan sir, they all have spoken a lot about the quality and the challenges they are facing, like the transformer which are failing, and he has emphasized too much on the oil quality, new oil not being used while testing the transformer, the oil quality, and many aspects. So with this, I'm slightly making a change in the sequence. Now I request Mr. Amandeep Singh ji, again from Power Grid DGM, to please speak on the maintenance, because I'm sure some of these challenges, the problems the people are facing can be minimized if the maintenance part is properly looked into. So I request Sri Amandeep Singh ji, and with a very humble request to please, because I'm getting a lot of requests for the questions also from the audience. So if you could try to keep his vital points within 15 minutes, maximum 20 minutes. After that, we'll have Sri Manoj Kumar ji, who will have a hard task. He being a major manufacturer in the country from BHEL side, how he is going to handle all these challenges and the innovations which he has been talking of. So now over to Sri Amandeep Singh ji from Power Grid.
Thank you very much, Sanjay ji, and good morning to all the esteemed speakers, Director Transmission from Telangana. First of all, I would like to acknowledge Sanjay ji's effort, and on behalf of IMA and ITMA, he has done a lot of effort in putting this seminar together, and I'm seeing a lot of very learned guys also in the participants who have come for these sessions. I mean, I'm seeing a lot of our partners also who are working in transformer industry from various vendors also. And I would also like to just request Sanjay ji ki towards the end, I also see Dr. Rajesh Arora is also joined. He is also a very prominent member from DTL. Towards the end, if you can just request him to also share his views on these topics for just 4 to 5 minutes, then it would be, I think it would be a very good opportunity. So,
Sure, sir, definitely.
okay, thank you. So just coming back to our topics, and you have cut out a very hard task for us all, sticking all this information in 15 minutes period is not possible. So I just gave up on the concept of preparing a presentation because it's not possible to squeeze in all this information. I would just like to briefly touch upon जैसे कि आप सब लोगों ने towards स्टार्ट ऑफ द सेशन बोला था, गुंजन सर ने भी इस चीज को किया था कि ग्लोबली इफ वी सी द फेलियर रेट ऑफ ट्रांसफार्मर रिएक्टर्स इज 0.5%. It varies of course with the voltage level. For 765 kV it may be 0.33%, but overall generally it's agreed that around 0.5% global failure rate is acknowledged everywhere. But in power grid we have managed to have a failure rate of almost 50% of that. Our failure rate is 0.26%, and it is a consistent failure rate. I would just like to make a small submission to our partners from Telangana team. Sir, as per SIGRE, calculation is done based on the service life period. So if you would account for that service life period, then maybe your failure rate would be more consistent. Otherwise it is appearing that and some points it is 1.14%, at others it's 0.3%. So it does not give a clear signal to the management and the decision maker, the asset managers. So it's better to adopt the SIGRE failure rate for calculation of the failure rate, which gives us a very consistent result, because it takes into account that the older equipment, once it has given a service of 20 or 25 periods, 25 years of service life, then it's more likely to fail, and it is going to have a lesser impact on the failure rate. But if a equipment is failure within, let us say 3 years or 4 years or 5 years, then that means that transformer has not failed. It has failed and to perform its duty, and it's more of at fault. So we need to acknowledge those aspects when we are talking about the reliability of a very reliable equipment like transformer, which is delivering power so efficiently across this different voltage levels. So coming back to my topic, like I just said, Power Grid has been able to maintain a failure rate of 0.26%, and we have done this consistently due to adoption of maintenance practices. See, when Power Grid started in 91, when we formally started, there was no as such established maintenance plan. So maintenance was done mostly on time-based aspect or condition-based aspects. But slowly, as we evolved, we learned that we need to adopt more reliability-centric maintenance aspects. And for that, we have adopted many online and offline monitoring techniques. Like just to briefly touch upon online monitoring, like we have done for online DGA, we have experimented with online PD monitoring. Even we have tried our hands at bushing monitoring and then temperature measurement, and taking into aspect the loading and the impact that this loading is going to have on the thermal parameters of the transformer. Besides that, we have also adopted some of the leading condition monitoring techniques which are done offline, techniques like tan delta measurement, variable frequency tan delta we have also adopted, FDS we have a frequency. So these all topics are very elaborate, they require a lot of thought process, and I know that I will not be able to touch upon all these topics in 15 minutes. So that is why I'll just briefly give the audience a taste of what all is being done in Power Grid. We have also We are one of the few utilities. In fact, we are the fourth utility worldwide who has started a methanol marker test kit. Now, methanol marker, what it does is it gives you an advance warning whenever the aging is going to happen. Just to give you an analogy, let us say when you are 20 or 25 or 30, you can climb up a flight of stairs effortlessly. But as you approach 40, maybe climbing the same flight of stairs would be more exhaustive. जैसे सांस चढ़ जाएगी आपकी अगर जैसे सीढ़ियां चढ़ते हैं, तो that is just a sign that your body is now started to age. So methanol marker test kit is also something similar where we are trying to predict which of a transformer has started to showing aging signs, and then we can take preemptive action. We can look into whether there is something exceptional going on. We can identify the outliers, and we may even be able to predict the failure of an equipment. So prediction of the failure of the equipment is one of the it's a एक टास्क है, जो ऐसा टास्क है जो सारी यूटिलिटीज करना चाह रही हैं, वर्ल्ड वाइड करना चाह रही हैं, और पावर ग्रिड भी उनमें से एक यूटिलिटी है जो प्रिडिक्शन में बहुत सीरियसली काम कर रहे हैं. वी आर वर्किंग वेरी डिलिजेंटली इनटू डिजिटलाइजेशन. I think Power Grid is one of the first utility in India who has set up a dedicated digital cell, which is concentrating completely on implementation of digital aspects. हर एक चीज को हम कैसे एनालाइज कर सकते हैं बेटर, और हम प्रिडिक्ट कर सकते हैं. सो वी आर टेकिंग द हेल्प ऑफ आर्टिफिशियल इंटेलिजेंस. अभी जो पुराने पैरामीटर्स के रिजल्ट्स के बेसिस पर क्या हम ये प्रिडिक्ट कर पाएंगे कि हमारे इक्विपमेंट कौन सा है जो अगला फेल होने वाला है? इफ वी कैन डू दैट, इफ वी कैन इवन save one of our equipment based on our these technologies, then definitely, because on an average our transformer would cost around 15 to 20 crores. If we talk about a 500 MVA transformer, around 18 crores it would cost. So even saving one transformer, we would be able to save a huge amount of money. So artificial intelligence is a solution which is very attractive at this point of time. We are trying to implement a transformer intelligent condition monitoring software. We have already done one Power Grid asset life management software we have implemented, where transformer health is indexed, or it is predicted based on the past condition monitoring data. For example, winding time delta, bushing time delta, उसके DGA के क्या पैरामीटर्स हैं, ऑयल के क्या पैरामीटर्स हैं, उनकी वैल्यूज के बेसिस पे हम ये प्रिडिक्ट करते हैं कि कौन सा हमारे ट्रांसफार्मर हेल्दी हैं, कौन से ट्रांसफार्मर्स हैं जो हमारे कुछ क्रिटिकल हैं, मे बी ऑफ मीडियम क्रिटिकलिटी और सिवियर क्रिटिकलिटी. बट अब हम उसको नेक्स्ट स्टेप पे लेके जा रहे हैं, वेयर वी आर गोइंग टू प्रिडिक्ट व्हाट इज गोइंग टू हैपन इन द फ्यूचर. So this is one of the major something which many utilities are experimenting with, and they are working, and we are working very closely. And like Sanjay ji also said, हम आत्मनिर्भर हैं, तो we are not looking at this from an international perspective. हम किसी foreign vendors को बुला करके यहाँ नहीं करना चाह रहे हैं. हमारे इंडिया में ही बहुत टैलेंट है, तो हम इंडियन वेंडर्स के साथ ही काम करना चाह रहे हैं जो इंडिया में सॉफ्टवेयर में कुछ काम कर रहे हैं, या हमारी इन हाउस टीम है. हम सब मिलकर के ही इसको सॉल्व करेंगे ताकि हम लोग सेल्फ रिलायंट हो सकें. सो दिस इज व्हाट वी आर डूइंग ऑन एन मेंटेनेंस पॉइंट ऑफ व्यू. सो वी have like I said, we have adopted a lot of global practices. We are continuously trying to innovate. Of course, if later on the time permits, I can talk more about our SFRA techniques, or how FDS learning has helped us to save our equipment. But on an average, I would just give that, and on an estimated basis, every year around 4 to 5 transformer or reactor we are saving based on these advanced condition monitoring techniques. So 4 to 5 transformer reactors would amount to around 100 to 150 crore of rupees, which we are saving every year. So this is something that Power Grid has done over the past. And like Gunjan sir also mentioned, interchangeability is an issue. I would from this platform like to request all utilities, because there are still some utilities who are not adopting the standard technical specifications. तो उसमें ultimately problem comes with the utility itself. जैसे अभी कई बार हमको कोई यूटिलिटी से रिक्वेस्ट भी आती है कि अगर आपके पास कोई ट्रांसफॉर्मर रिएक्टर स्पेयर है, बट उनकी कोई यूनिक कॉन्फ़िगरेशन रहती हैं या यूनिक उनके डिजाइन रहते हैं, तो इन दैट केस जो चैलेंजेस रहेंगे तो उनके पार्ट पे भी रहेंगे. So if we are moving in an aligned way, in a very standardized way, then it would be to the benefit of all the parties concerned. So this is something that I just wanted to add apart from what I wanted to cover on the maintenance practices. तो इसके साथ मैं थैंक यू कहना चाहूंगा एक बार फिर संजय जी का. And I mean, I'm looking forward to a very interactive question and answer session for today's seminar. Thank you.
Thank you very much, sir. Now, Manoj Kumar, sir, I think you have been given a very tough task by PGC and Sri Amandeep Singh ji. Mr. Manoj Kumar is an electrical engineer. He has done his MTech from IIT Kanpur. He is heading transformer group of BHEL since last 31 years and has tried many new things in the field of innovation. So now what he has been talking about, so many challenges, artificial intelligence, predictive maintenance. Now you have to speak on everything. I hope everybody is very hopefully looking towards you as a leading transformer manufacturer of the country. How would you meet the expectations? So over to Mr. Manoj Kumar. Unmute kariye, sir. Sir, you have to unmute.
Thank you very much and good morning to all of you. I am Manoj Kumar, Additional General Manager, working in Transmission Business Group, not in the Transformer Group. Nevertheless, we are dealing in the transformers definitely. Initially, I had worked for 24 years for the engineering, for designing substations, selecting equipments. And after that was 7-8 years, I was in the construction group, where we had executed 2-3 substation projects for power grid, also at Bhuj substation, 765 kV, and many at Kothagudam also. I have worked there. So I would like to share a few things, though you know very well that BHEL is one of the leading manufacturing transformer company in India. We are manufacturing from 33 kV dry type transformer up to 1200 kV oil filled transformers. Apart from this, we are also manufacturing converter transformers for HVDC projects, which we had supplied for Niagara projects, Raichur Pugalur projects, and for the upcoming products, we are also geared up to supply our converter transformers. Recently, there is a requirement of STATCOM jobs in the market, for which coupling transformers will be required. That will be around 33 kV by 400 kV. Those transformers are also under our radar to manufacturers and to supply to utilities and to prove in the market. Now I will start from the very basic things. Let me share this screen. Can you see the screen? I hope you can see the screen.
Yes, sir. Okay, it's visible.
Yeah. So like a power transfer between the 2 points is dependent on the voltages at 2 points, sending and receiving end, and the angle between these two things. These voltages are being controlled like putting shunt capacitors, STATCOM, or many SVCs and many other devices. And for transfer, suppose you want to transmit more power in the line, just you put a series capacitors and reduce the line impedance. There is one more aspect, that is a delta. Now I will be covering this phase shifting transformer. If you will see, This is the studies which we had done for the Kothagudam and implemented also. In Kothagudam, this power from 220 kV generation stations was being transmitted through 220 kV line. With the addition of this 500 megawatt generated at Kothagudam, the power was to be transferred. Again, however, this 220 kV lines was overloaded and 400 kV lines was underloaded. So it was planned to put a transformer in between these two, between the 220 kV bus and 500 kV bus. Based on the system studies, it was looked upon that this 220 kV lines, which was already overloaded, power was being transferred from 400 kV side to 220 kV side, which was not desirable. So based on the system studies, BHEL has designed phase shifting transformer first time in India. That was a 400 kV that has already been installed at Kothagudam and working satisfactorily as on date. This transformers is basically controlling the power flow between these two 220 kV line and 400 kV bus as per my desired requirement. So I will be touching upon the principle how this power is being controlled, even being a passive element to the transformers, how this power transfer is being controlled. Here you can see for the Kothagudam, we have put two transformer units. One is 105 MVA series transformer, and one is a 400 kV ICT. Here in ICT, one more additional control winding has been generated. This gives a voltage and it is being injected to the series transformer winding. This controls the phase angle between between the two ends of the transformer, which is the ICT, like this. Suppose there are three phase voltage A, B, C, and I inject voltage, this is the B minus C, then I can change my control angle alpha. This alpha angle control effectively can transfer the power in the desired mode from this place to this place. So BHEL is the only agency in India who has developed this phase shifting transformer, where we can provide phase shifting of plus minus 15 degree angle, and we can control roughly 150 megawatt transfer power from this 220 kV side to 400 kV side and vice versa. It is satisfactorily working at the Kothagudam station as on date. It was commissioned in 2014. And BHEL is again pioneering and this working for 800 kV phase shifting transformers to put into the network. These are the physical pictures of those transformers developed by BHEL. This is the series transformer unit. This is the sun transformer unit. Those were tested specifically. These are their control windings. We are tapping the voltages from the control windings, putting into the series, and we are adding phase angle to the two ends of the transformer and controlling the voltage power flow into the system. Just to control how much I have to change the power flow, I have to control the phase angle alpha. This alpha I can control by putting OLTC. OLTC is already installed in the transformers. By sitting in the control room itself, I can change the OLTC value, and by changing the OLTC step value, I can control the power flow in the transmission line. So this is the one of the pioneer which BHEL has done, phase shifting transformers being utilized in many network globally, but in India, this is the only one which we have tested and commercially implemented also, and it is working satisfactorily as on date. This PST helps us in reducing the losses, because whenever there are overloaded lines are there, we can transfer power to the other loops. This transformers effectively is being used to optimize the power flow in the transmission network, reducing the system losses, and to control the active power flows into the network. This is one of the items BHEL has made it and successfully tested also. This is the physical picture one can see. These are the series transformers. These are the shunt transformers, and this has been successfully commissioned at Kotaguda. Now I will touch upon another thing, that is a shunt reactors that is also developed by BHEL. Normally in the reactors portion, if you will see, those reactors are permanently connected to the line, to the bus at the end, and continuously, even if there is a not requirement of those reactors, those are continuously connected. Pardon? And these are continuously drawing power from the network, even if those are not required. Though reactors are meant whenever there is a voltage is higher than the desired voltage. So in that case, BHEL has developed transformers that is a basically shunt reactors where there is a secondary winding. This secondary winding is connected through circuit breaker that is a low voltage winding, let us say 33 kV winding. And by this one, whenever this secondary is open, it does not draw any current from the network. Like this, in this situation, it is not drawing any current from the network, and MVR is 0. Whenever I close this breaker, this draws the complete reactive current from the network, and the complete reactor comes into the picture. So those reactors BHEL has supplied once in 2001 to Power Grid, which is working at Itarsi. Later on in 2008 and 9, it was supplied at Mahatransco at Dhule and Karad. And Dhule, there were two reactors, that was a 2 into 50 MVAs, and at the Karad, there were 180 MVAs reactors. Effectively, these are the new things BHEL has developed apart from those things which is being done by the others manufacturers. So, I mean, just you had asked me to add what are the new things BHEL has done, though most of the things like Gunjan sir has also added and other speakers have added. Definitely my transformer team who are really manufacturing, they can contribute a lot of more on this. But whatever the new developments BHEL has done, and we are in the process that we have shared with you. Now, recently, for the coming STATCOM projects, we are going to work for this intermediate transformer 33 kV by 400 kV, which will be covering harmonics portion also. And converter transformer, definitely with the help of other manufacturers with the design of those, BHEL has already supplied several transformers throughout India for the HVDC projects. So with this, I have shared the recent development BHEL has carried out and already supplied, implemented, and successfully working based on the system studies and the requirement of the systems. With this, I will say thank you very much. And I will say if the other speaker can contribute more.
Thank you very much, Manoj sir. We have discussed the challenges by Jagat Reddy sir. We
Yes.
have discussed the quality issues by Gunjan sir from PGCIL, the maintenance aspects by Amandeep sir. Now, anything is possible, anything can be achieved. But there is a very important thing, the cost implication of that. If you want a BMW, one should be willing to pay the price of the BMW, not the price of Maruti 800. Therefore, the next major topic of interest is the cost optimization. We want too many things. He has wonderfully spoken on innovations. I hope the Telangana Transco, so many friends have taken a note of what BHEL is doing in the field of innovation. To me, as a layman, it seems wonderful. So now I come to Sri Richik Das. He has almost 20 years of experience in design, manufacturing, testing, and he had worked with organizations like Siemens, GE, published many papers in CBIP, GridTech, Trafotech. Now presently, he is chief manager with Power Grid. So I request Richik Das sir to speak how the cost can be optimized, how can the Indian transformer industry be globally competitive, and how can we achieve cost, quality, innovation, and speed of delivery at a cost. Definitely, if I put China as a benchmark to meet the China in terms of all these cost, quality, innovation, and the speed of development, the speed of delivery, that is. So over to you, sir. Richik Das sir from PGCIL. Sir, yeah.
Thank you, Sanjay sir, for your nice words. And I convey my sincere regards to all my seniors before start my presentation. See, this is a very challenging topic and time is very less. So I make small presentation on this topic. Let me share this. Sir, my screen is visible?
Yes, it is visible.
Visible.
Thank you, sir. So the topic is very important topic in today's scenario: transformer cost optimization and cost minimization and optimization. So as you know, that the role of transformer. Yeah, the role of transformers. See, transformer is one of the vital component in electrical network, as we know, and is continuous performance is very much required to retain the network availability. So what is our requirement? Our requirement is to, it provides the best performance, low maintenance cost, and long life, and low material cost. So basically, transformer, we should have very reliable and with very low cost, and it must have very long life. So how to achieve and how to compensate the challenges? So basically, if you see the transformer cost, how what are the parameters governed by the transformer cost? Basically, the raw materials, manufacturing, maintenance, and design practice. So these are the major criteria which govern the cost of the transformers. So what is our aim? How to minimize the cost? So not only the material cost. So we should have optimized design with adequate safety margins. So optimized design means we reduce the design margin, we reduce the size of the transformer with all that things will not serve our purpose. So basically, we have to have optimized design. At the same time, we have to maintain the safety margin, because today's complexity in the grid is more and more. It is adding up. So we have to think on that part also. Then design tools and expertise. So basically, in today's scenario, if you see the transformer rating is increased day by day. So we have to have the good design tools that can calculate accurately the various conditions, like dielectric conditions, like thermal conditions, like mechanical integrity. So all three major things we have to check through the design tool. And now we have the state-of-the-art design tool by so many manufacturers they have. So they can calculate very precisely the different conditions of the transformer and to check the adequate safety margin in all aspects. And at the same time expertise. So expertise in all the areas, not only in the design but also in the field of manufacturing, in the field of testing. So everywhere we need the expert person, expert skill, so that can help to make the good transformers. So and the standardization, what I think Gunjan sir also nicely covered the various topics, various points. So the standardization is one of the important part of this. So how we can standardize, because what is the benefit of the standardization? See, as Sanjay sir also telling that the like example of car. So car is a auto, or in the automatic industries, it is mass production through the machines. So but transformer is not like that, but we have to have the manufacturing practice such a way that it is a kind of the same product we are manufacturing, the skill they develop, it will adapt their that view in the manufacturing process. So in that case standardization is very important. So standardization in the design, standardization in the manufacturing process, standardization in the testing. So everywhere, if you follow, if you adapt the standardization, then your making the transformer time cycle will be also reduced, and you have the reliability on the product. So what are the manufacturing aspects we have to look into it? Our objective is to transformer, we have to manufacture the transformer complying the design document without deviating manufacturing process, basically quality, to achieve no failure during testing and site. So if the transformer is manufactured without failure and it runs successfully at site, so that is our requirement. So if it fulfills by this process, then definitely we have saved times, we have saved a lot of money for the failures. So that will definitely significantly reduce the cost of the transformers indirectly. So failure means, as I said, the test bed failure or at site. So once failure, as I said, if failures either in test bed or site, that means you have to reopen the transformer, you have to change the things what is failed for, then again made it for testing. So this process again and again we have to adapt. So that will delay your process, that will delay with other transformers. So these things is very important when you make a transformer. So we have to think that any process, any things we don't have to bypass, or that will that don't avoid the quality aspect. So always we have to look into this matter, so that transformer the manufactured transformer should be with good quality, and it will pass successfully, and it will give the good signature at site. So good manufacturing practice is very much important, and it is inevitable for today's scenario because of the large rating of transformers are coming day by day. So next is that we have to think long term. Basically, we manufacture it and it runs for the few years. It is not like that. Basically, transformer is for long life. It should works for like as we have 35 years. It should minimum it should operate. So for that time we have to think for what are the parameters, what are the design aspect. We have to look into it so that we can provide long life without any disturbance. And again, it is a customized product, as I said. So every stage human interventions are there in the manufacturing. So skill, knowledge is very important, and everybody who are involved in the process, they should know what are the consequences in every stages. See if we are it is manufacturing at manufacturer works. So every persons who are dealing the product, they should know if this lead is going that way, so what are the impact. If lead is going that way, so what the adverse effect will be there. So these things always to be known. So that means for this, manufacturer also make their internal training periodically, so that every persons involved, they also know the process. Then the testing aspect. So basically, after design, it should be validated. The manufacturing process has to be validated, and the material what we are using. So that thing is validated by testing and successful operation at site. So this testing is very important, and it is very much required. And we have to do the testing in proper manner. Proper manner means that all the sequence, all the voltage parameters on the current, losses, everything has to be checked properly. So without bypassing or less knowledge in that case, that means we are bypassing the process, and so transformer testing is not proper, then you will not get the correct history of the transformer. Then there may be some problem at site. So what purpose the transformer is designed, that things has to be verified by testing. So testing also to be done with all maintaining or complying all the requirement in the specification what customers wants. So then we go to the raw material. What are the component involved in the transformers which have like a great impact in the cost? So if you see here, the typical table I have taken for the large transformer. So don't go by for small rating or distribution transformer. This typical value for large transformers. So if you see, we have CRGO, copper, insulating material, bushing, and OLTC and other associated equipment. So here you can see that the table here, that CRGO is 20 to 25% cost is government, copper is 25 to 30%, insulating oil is 7 to 10%, insulation is 7 to 10%, bushing and OLTC 10 to 15%, steel again 7 to 10%, and other fittings 2 to 5%. So major cost is governed by CRGO, copper, and insulating oil and press board. So these things we have to check how we can reduce in the design, but we have to maintain the quality, we have to maintain the design margin. That things also we have to look into it. So how we can do best CRGO. So as far as design is concerned, now we have very good kind of CRGO, because earlier the CRGO type was only M4. M4 means only conventional grade of CRGO we are having. Now most of the manufacturing plant in basically CRGO is also we are outsourced. So it is having high permeability grade, and we should ensure that the CRGO should have high permeability grade, that means HP grade. And all the designers should design the transformer with optimum flux density, because the CRGO with high permeability can withstand high flux density with low loss. So that things also should take care by the designer. And the quality aspect. So basically the material, all the material is coming from outside. So this is also our great challenge. So this material, whether it is good or bad, that is being again confirmed by the BI certification. Then the availability is the foreign suppliers we have. So here our thing is that we should have some Indian manufacturer. We are trying, our government is also trying for long time. So let's see, and if we have the CRGO manufacturer, that will also helps a lot, because this also delivery of this CRGO, because if you not get that product in time, so that will also delay our process. So these things we have to look, and many manufacturers may order bulk order CRGO for their transformers and the timely delivery. So basically the challenge is the majority of the CRGO material is imported. We should do indigenization, and availability of the appropriate grade is also major challenge. Sometimes we face the transformer should have this grade, but manufacturer is not having because of the non-availability, because of the scarcity, and because of the it is taking time, but transformer we need urgently. So these various things are involved, and that's why the availability of the proper grade also a challenge in this time. Then the copper. So as Gunjan sir said that the CA has made the standardization of the transformers. So now we have only standard design, and every design you will see the reduced loss design. So transformer loss with very much low loss value. So here I want to say that manufacturer have to analyze that whether they go for CTC conductor or normal PICC conductor, because CTC conductor have very great advantage in this aspect. So lesser manufacturing cycle for winding with CTC, lesser difficulty during winding manufacturing. CTC is preferred as the high dynamic short circuit is concerned, high mechanical integrity with CTC conductor, epoxy coated. So manufacturers should adapt the CTC type of conductor for high current rating winding, so that their design margin will be more, their design will be more rigid, and it can withstand short circuit force nicely. So these things, because it will also reduce your time cycle, manufacturing time cycle. So the manufacturer have to see this will help a lot in during their design. Then we have to go for the insulation. See, insulation also very important aspect in the transformer, because the weak part of the transformer is insulation. So here you can see the raw material and the basically pulp, these are all are imported. So here we don't have, the Indian environment is not like that to we have such material. So we have to have dependent on this material, but we have a great scope that we can adding the insulation plants facilities for assembly, cutting, processing. This we should have more and more, and with this we can fulfill the requirement of the demand for these items. Because for large rating transformer, if you see the CTU their rolling plan in up to 27-28, there are many transformers is required, transformers and reactors. So to cope up with this demand, such kinds of initiative by manufacturers should take, and they can have the availability of the transformer in time. Then insulation storage. So this item is very critical and very it is very much risk involved. How? That means if we have the moisture, if we have the contaminations, then and your functional requirement of the insulation will jeopardize. So we should have good storage of the insulations. Then the bushing is also very critical component in the transformers. Power grid have taken I think almost decades ago that we have the YP bushing and lot many failures, and seeing the world trend, and we adapt the RIP and RIS bushing, and this bushing is really their performance is fantastic with respect to YP bushing. And we have developed many, because earlier it was always imported, and we have developed so many manufacturers in initiative by Government of India through Make in India and Atmanirbhar Bharat initiatives. And here also there is a scope, because bushing such a item in one transformer you can see 9 bushings are required. So the scope of development for more and more bushing suppliers in India to be there. So manufacturers may look into this aspect, and we should have the bushing in time. Sometimes bushing also delay our projects. So these things also have a scope, and if we have more Indian suppliers, then also definitely the cost will be reduced. So all these aspects also related to cost. Then insulating oil. See, the future is mineral oil will be outdated, because the availability is limited. So we have to have only option for ester-based insulating fluids, the synthetic and the natural ester. So again, this thing is very important, and manufacturers should adapt this technology very fast. Otherwise, again, there will be a problem. So in the global scenario, if you see so many manufacturers and utility, they are doing a lot of research on this topics, and Power Grid also doing, and we have successfully commissioned one 400 kV reactor with natural ester, and we are planning to have one transformer also 400 kV with synthetic esters, and also we are doing some retrofilling of transformers and reactors with ester-based fluid. So this is the next generation's requirement, and many manufacturers should have to come with this solution, and definitely the cost of the oil will be reduced if the demand is increased day by day. So this is also major challenge for our. Then again, this was the new material, and then the how to handle. because good storage again is required for the oil. The oil is also is an insulation and also cooling purpose. So if we have the good handling facility, then the less contaminations, and if we have a good you will see the good parameters like tan delta, interfacial tensions, and all other parameter will be will have good value, and it will give the transformer long life. Then periodical testing of used oil, as Gunjan sir is very nicely explained, that manufacturers generally use the used oil for the testing purpose, and see this oil is, because this is oil first time is into the going into the transformers, and it is impregnated throughout all the insulation. So these oil parameters should be very, very good. Otherwise the transformer life have a great impact on this. So bad oil deteriorates the property of the insulation material. So we should take proper, again, as far as commissioning is concerned, we should take good precautions when the new oil is coming, how to process, how to handle, so that the oil parameters should not deteriorate during commissioning. Then finally we can come to the conclusion. So what are our summary? That we always have to analyze the risk. So risk assessment is very much required in every stages, and based on that, and we should calculate how the price implications we can reduce, but without compromising the quality and the safety margin. Then design optimization, adequate design margins. So material, manufacturing practice, environment, everything, what are the parameters involved, the safety margin, that thing also look into it. Manufacturing practice, quality, and our aim is to no failure. So what are the steps every day we are taking, that has to be improved, so that failure rate will be reduced. Then material planning, then ensure timely procurement of the raw material. As I said, that now we are having the renewable energy are coming day by day increased, and it will reduce our thermal energy. So the time period is very the transformer life cycle is reduced. See, earlier we have the transformer with for 24 months. Now this transformer we should have 11-12 months. So because of the integration of the renewable energy, which is that gestation period is very less compared to the thermal power plant. So how to cope up with this? So what are the raw material and their availability, and during if we delay, basically delay means you have to pay LD, or delay means your production capacity will be reduced. So all the things will link into your financial condition. So that thing also do with proper planning and material availability. Then indigenization, as I said, the scope of the transformer. Then now again I say that the new transformers, new special type of transformers are integrated day by day in the grid. So this special application transformer designer, we should have good manufacturer for these kinds of special transformers. Standardization, as I said, and grid complexities, as I also explained, that it is also a great challenge for us. Again, I say that though the technology is mature, transformer is a very old technology, still more research are required for EHV and UHV class transformer design, specifically in the field of dielectric. Then again, I say that high impedance transformer for better short circuit withstand capability also may we can have that will reduce the short circuit failure rate, because high impedance means it can have the good withstand capability. And because day by day our system is increasing, fault level is increasing, so there's things also to be looked into it. This way we can improve and we can challenge, we can reduce the cost of the transformers. So that's all from my side. I think very short period of time, that's why I make very precise. Thank you, sir.
Thank you, Ritika sir. I find this brief interaction on transformers very, very valuable. Now I request a very special speaker, as requested by Shri Amandeep Singh ji. We have an expert in this field. Luckily, we are lucky to have him with us today in this seminar, Dr. Rajesh Arora. So I request him to please speak a few wisdomful words on the topic of his choice and make this seminar more enriching.
Thank you, sir. Thanks
Dr.
a lot.
Rajesh Arora. Sir, please put your video on so that I can put the spotlight on you.
Okay, okay.
Yeah,
Is it okay?
checking.
It's
So
okay,
you
right?
can start. I'm telling my organizing team to take you on the front. Yeah,
Okay.
please.
First of all, thank you, Sanjay ji, and good morning, good afternoon to everyone. And thank you very much for giving me this opportunity to speak on very important topic of transformer. All the speakers have already expressed their view and they have given very good deliberation on that important topic. And when we talk about the transformer asset at the utility and the substation, and you have to take care of it, one transformer failure can reduce your total availability, and it can reduce your downtime. And to cope up with all these things, the very first thing, the quality very well taken by Gunjan sir, then the maintenance very well taken by power grid sir, Amandeep ji, and then the manufacturer challenges by power that BHL, they have come up with new technology, very good. And basically what happens, we always rely on the shunt reactor only to take care of our reactor reactive power requirement. And he has also given new things about new CRGO, new oil. And apart from that, what I feel, apart from that quality we have already discussed, the time has come to talk about to utilize the artificial intelligence. We have to work on the digital twin, because we can predict what is going on, but what is going to be in the future, that very well taken by Amandeep ji. We have to take care of, we have to utilize the available technology in the world like artificial intelligence and digital twin that can tell you what is going to happen with your transformer in the future. Because one outage of one transformer costs many things. It reduces your availability, it reduces your downtime, it creates, it basically it has direct impact on the tariff also, because finally any failure has direct impact on the ARR, and that ARR has direct impact on the tariff and the pocket of every citizen in the India. Thank you once again for giving me that opportunity, but I feel the quality should be most focus point for all the utility, and apart from that, the proper maintenance technique as explained by Amandeep ji, and we have to use new upcoming technology like artificial intelligence to save our transformers, the most important assets for any utility. Thank you, sir. Thank you very much.
Very much, Dr. Rajesh Arora. Now to the eminent speakers, we have few questions also. I've got a lot of queries on my WhatsApp also. But anyway, I'll try to take one by one. One question is, what is expected factors of safety from utility point of view in terms of dielectric design, short circuit design, and thermal design? A question to Sri Richik Manas Das. Sir, a question for you, if you could kindly answer that from the audience.
This safety factor, basically what I want to say that utility have their own specification. So they have mentioned their BIL level of the equipment, it based on the system study. And sometimes standard parameters is available in the international and national standard. So manufacturer have to design their transformers with considering that the voltage mentioned in the specification, because their equipment should perform in the grid with that suitable for that voltage, like impulse, switching impulse, power frequency, chopped impulse, that has to be passed, and during operation, and the voltage is not cross that. So manufacturers should take care for withstanding that voltage, for how much margin they are required, considering their design practice, considering their material they have used, what environment they are using, what manufacturer skill is there. So adding to that, safety margin is to be maintained by manufacturer to have the successful testing of the product with desired level. I hope I have answered.
Thank you very much, sir. The second question is, I hope if either Gunjan sir or Sri Jagat Reddy sir could answer that. Despite the best B grade CRGO available, manufacturers still specify 1.6 operating flux density. What is the remedy for this, sir?
I think this can be answered by Mr. Rijik best.
Yeah.
Sir, once again, you just repeat this question so that again I can.
Despite the best high B grade CRGO available, manufacturers still specify 1.6 operating flux density.
See, as I said, that flux density you can optimize because we have very good CRGO material. Now we have high permeability grade CRGO. So basically, we have to see the characteristics of the CRGO. So CRGO, basically, why you change the grade? Change the grade means it has good characteristics in terms of saturation and in terms of loss. So if I have to reduce the loss, we have to have good material, and we have seen, we have experienced that at more than 2 Tesla, the core is saturated. It's saturated or it is going to be saturated. So if we design the transformer maybe at 1.7 Tesla, and if the transformer should run 110% also over voltage, that also reach 1.9 Tesla, and that is also very good value for operation continuously. So if you see the CA specification, here they have mentioned that the parameter, the condition they have mentioned, and accordingly 1.7 Tesla is a good value, unless otherwise utility have their other requirement. See, 1.67 Tesla is very good value for now today's transformer with very good CRGO.
I hope the person who has asked question is satisfied. Now, sir, with this, if there is anyone more, so many questions are coming, but seeing the paucity of time and the importance of you esteemed speakers, we are very much on time, reaching towards the end of the seminar. My request is, sir, India as a country is trying many new things. Make in India, Atmanirbhar, many new concepts are coming. India is progressing. On global front, we really as a country have a very nice opportunity to emerge as a global supplier for many items. And the support of you people is too much needed. The way you have interacted and shared your wisdomful knowledge, your practical experiences, Jagat Reddy ji, Gunjan sir, Richik Das sir, Manoj ji, you have talked of innovation. Really, if you permit and come for many such interactive seminars, people are going to stand benefited a lot. Your slide guidance, your finger pointing to the direction that this is the direction you people need to go, travel, it will really help to us, the manufacturers, to business community, almost more than 100 transformer manufacturers and the people related in the trade have been benefited. So I hope there will be many more such attempts on different topics, the interactive seminars, and your guidance would always be appreciated. Welcome. So with this, sir, I will request the senior most member here with experience, and the nice thing he said, at this age also he is doing his PhD. Sri Jagat Reddy sir, I will request him to say some few concluding remarks about this attempt for this interactive session. And I would also request him to communicate his vote of thanks to all the speakers here and the people who have attended this seminar. Dr. Jagat Reddy sir.
Mr. Agarwal, before signing off, may I say something?
Please, sir, please.
Thank you. You see, I am Pradeep Agarwal. I am Vice President of ITMA, and we are manufacturing transformers in the last 45 years. So I have a long experience on this.
Sir, can you put your video on so that you are taken on the screen? Yeah,
My
no
video-
problem, sir. I'm telling my team to do it. Please
My
go ahead,
video is
sir.
on.
Yeah.
Am I
Yeah, sir,
clear?
please continue. Sorry. Yeah.
Yeah. You see, we are into manufacturing of transformers, mainly maybe distribution side, for the last 40 years. You see, what my question or query to the house is that we are very much concerned about quality. And the main, I would say, the people governing this, the main regulators in this are BIS and maybe BE for the losses part. So my question to the house is that when we are so much concerned about the quality, why is BIS restricting itself only up to 2,500 kVA? Why isn't BIS doing something about power transformers? Why isn't it making some mandatory stipulation for power transformers? Similarly, regarding quality, regarding maintenance, regarding damage, we have spoken a lot. Mr. Manoj Kumar has also said much about it, but I feel that nothing has been said about the operation part. You see, in a transformer failure, operation counts very much. In fact, I would say it counts more than the manufacturing part. Because you see, now what is happening is that the electricity boards, the discoms, are going in for large warranties. They're going in for maybe 7 years unconditional warranty. As a result, maintenance is being overlooked. So this is leading to more failure, I would say, because the discoms are not bothered. They're saying that it's just a matter of getting it repaired free of cost from the manufacturer. Anybody can throw some light on this.
Hello. Hello.
Yeah.
Hello, this is Jagat Reddy, Director Transmission from Telangana. Hello.
Yeah, sir, please continue.
Yeah, I think I can talk about these distribution transformers also. As he said, both are responsible, the utilities and as well as the manufacturers. See, but the people manufacturers knows to which utility they are supplying. To which utility they are supplying, what is the utility, how it is, how the utility is, how the LT network. Those things has to be taken into consideration. It is different from different utilities. The network maintenance is different for different utilities. This has to be taken into consideration by a manufacturer while he is quoting for the participating in the bid for the order. Yes, both are at in loggerheads, either the manufacturers or the transmission companies or distribution companies, even the manufacturers also. I'll show some figures. I have seen some transformers which have failed within 5 years, which have failed within 10 years. Lot of carelessness is there in the process of manufacturing. I don't say about the company value, their motive, but the people who are involved in the manufacturing of the process manufacturing pieces. Proper care is not being taken. As the other gentleman said about the oil, see how frequently they are testing the oil. What is the percentages, means various factors in the oil. That has to be taken in because that is the most vulnerable thing which is going to spoil the insulation of the transformer when if it is not good. That has to be seen. To what extent they are ensuring. I have seen number of bolts, rods left in the transformers, which are causing for thermal faults. We have opened the transformers. I have number of 35 transformers we have opened. See where the thermal fault is there. Mostly it is the carelessness in the manufacturing process. Core coil assembly, how they are doing. See, I feel that even in the specifications, BIS or even CEA specification for the power transformers, there is a lot of flexibility is being given. That's why people are not able to manufacture. Some are specifications, some are things, means factors has to be added to the specification. There must be a limitation of losses. Losses has to be mentioned. Flex density has to be mentioned. Everything, core quality, core grade has to be mentioned. Then everybody can quote equivalent prices. Lot of flexibility is given to the manufacturer, and see some one or two spurious manufacturers are spoiling the specifications, are spoiling the prices. See, that is, you see, the facts which we have to talk about the facts. See, keeping it something in mind and something in think, we cannot. If we go on speaking like this, nothing improves. It doesn't improve. Even in the power transformers also, even in the distribution transformers. See, I have seen one transformer. I have replaced 150 MA transformer with an 80 MA transformer. When I went to the site, when the transformer is under execution, the 50 MA transformer total, after all, what is there in the transformer? It is oil, core, means copper, and the steel. The material utilization is directly proportional to the cost of the transformer. See, the 80 MA transformer was 81 tons, 79 tons total weight. And the 50 MA transformer which was being replaced is 81 tons. The 80 MA transformer weight means 2 tons less than. The oil quantity has been reduced. 10,000 liters oil quantity has been reduced. Of course, the core weight has little 1 or 2 tons to 3 tons was more. 3 tons. What type of designs? I do not know. How these designs has to be seized everywhere. The specification, either CEA or any other BAS agency, there must not be any big scope for the manufacturer, any manufacturer, to manufacture different types of transformers. See, this is it is the quality of the transformers that are coming. We have to see we are going to have presently our generation capacity in all over India is 4.2 gigawatts. Now we are planning to go for 760 gigawatts, 760 gigawatts. What is the transformer capacity required in these 5-6 years by 2030? About 500 gigawatt means MEA is required by Indian utilities. We have to see whether the manufacturers has got that capacity and the quality manufacturing. See, I feel that if the transformer is manufactured and transformer manufacturing is taken properly, then it doesn't fail. Yes, there are some utilities whose network is poor, whose network is. I have seen the transformer. I have, in the last 8 years, being the director of the transmission company, 13 transformers have failed within the guarantee period, that is 5 years. And another 13 transformers have failed in 10 years. See, all of them, when we opened the transformer, either with the manufacturer or at our site, there are some faults found in this transformer. Manufacturing, in the process of manufacturing. I have argued, I have convinced the people manufacturer that there must be a manufacturing. Yes, bolts or nuts are left core while lifting the transformer, while assembling the core. By the time, I do not know how it has been handled in the transportation. See, lot of care has to be taken in the process of manufacturing, in the process of core coil assembly. The oil that has been used for testing the first oil that has been used for testing transformer or means commissioning transformer has to be tested. See, and transportation. No manufacturer doesn't want to manufacture the transformer. But your thoughts are not there in the people who are assembling the transformer. The company owners' thoughts are not there. You have to put proper people there to see it, how it is being manufactured, how it is being assembled. lot of transformers that are being failed in the guarantee period. The faults 80% is attributable to manufacturing. I have seen, as I've physically seen it, and about 20% of transformer attributable, as this gentleman said, is because of the transmission network or distribution network and the faults that are coming on the transformers. See, you have guaranteed some short circuits, number of short circuits. How many short circuits that transformer has got over a period of time? For 5 kA, very recently, on 80 mA transformer has 5 kA fault. See, this manufacturing, see, I suggest the manufacturers, because many of them are there in the seminar. I suggest the manufacturers. The process of manufacturing, in the process of manufacturing, your supervision has to be increased. And the transportation. People have said a lot of commissioning tests. See, one engineer, you are sending one engineer who doesn't know the testing, commissioning. He wants to go back as early as possible to his place. Please, I am not blaming anybody. I am not blaming. Faults are there on both sides. We have to cover it up. I request the people, I request the manufacturers, I request the utilities. I think it's my view is that we have to strengthen the specification so that everybody on the same platform to manufacture the quality transformers. We have to mention a lot of specification. The flexibility there in the specification, either in the CEA specification or BS, a lot of flexibility is there. I think we are not so good to, we have to have the limitation. We have to fix the parameters everywhere, wherever it is possible. Then give the specification for manufacturing so that nobody plays a game to quote the lowest prices. You should not have the fact means facility to quote for a low quality transformer, and the others are deprived of the people who have thoughts to manufacture the best transformer will deprived of the orders. This is my view. In distribution company, when I was executive engineer, assistant executive engineer, I was in procurement of distribution transformers for about 10 years. Of course, some of the transformers are designed, and we have standardized the specification in distribution company in Andhra Pradesh, combined Andhra Pradesh state. And I thought we got a number of good transformers by all the manufacturers, So I think still we should not have the flexibility what is there now in the CA, means CA specification and even BI specifications. Of course, very recently steps has been taken. Further steps has to be taken to manufacture a better transformer. Thing else, I do not know whether I've spoken, but what is there in my mind I spoke.
Sir, every industry wherever go, they have their own challenges. Today we have discussed the cost, quality, innovation, challenges, and out of all this manthan, some 2 or 3 officers have still that remark which I am carrying with me is our failure rate of transformers is much lesser than the international average failure rate. This is the, I would say, the buzz line, the something which is complemented to all. We have come a great far. We have to still do a lot of things. But my request to all these esteemed speakers is, again, repeatedly, the industry, the manufacturers, the we people need a lot of your wisdomful guidance, your interactions, your valuable advices, and definitely as a country, we will emerge winner. With this, we are right on time. I once again thank you very much for your precious time you have spent with all of us. It has been a very, very gainful day for each one of us. With that, I wish your kind permission, especially the permission of Mr. Amandeep Singh ji, who has been truly one of the pioneers, one of the guiding person, always supporting for all these kind of interactive sessions all the time. And thank you very much, Sri Jagat Reddy sir. Thank you very much, Manoj Kumar ji, BHEL, Kunjan sir, Richard Das sir, and the last, that crash gate entry, Dr. Arora, the showstopper, which normally we call in a fashion. So thank you very much, sir. Unless somebody has something very specific to comment, I need the permission of you all to sign off. Right, sir?
Thank you, sir. Thank you.
Thank you very
sir.
much, sir.
Thanks,
Thanks
sir.
a lot.
Thank
you, sir. Thank you.
Thank you, Sanjay ji and other members.
Thank you, sir.
Thank you, sir. Thank you. Thank you,
Thank you.
Sanjay ji.